Good evening. This is Piyush Arora. My topic is applications of regular expressions in search engine optimization. This is for the digital assignment 3 given by Professor Shivani Gupta. So I'll be starting by discussing the conversion of regular expression to finite automata, like how finite automata reads a regular expression. So regular expressions describe set of strings that are accepted by a language. That language is generated by a grammar as we have seen in the class. They are written in some algebraic form like we put asterisks, characters, then some plus symbol, commas. That's for all the deterministic and all the regular languages. Since we are dealing with regular expressions, and we have the in Python we have a library called RE, which is based on this concept of regular expressions. In there we can search for patterns in a given string, which is basically the goal of regular expressions. Then what my topic is search engine optimization. So regular expressions find a lot of applications in search engine optimization, which is like matching URLs, searching for web addresses from a large set of data. Like Google has such a large data. Now we need to optimize so that we can get in efficient time. And then we can also filter scam or spam content and then find typical phrases to filter out. Like if an email is mentioned as a spam, then we'll write spam, then it will generate, give all the spam emails. We can filter them out. Here I have discussed an example like how ABC pattern can be found in a string CAB ABC. So the reggae solution will start by reading the first C, then it will match that with A. Now this is a mismatch. Now it will move forward. Now the next characters A and B in the string, they match the first and second condition of the regex, but failed at the character B because after B there is C. So at C it failed, right? So now we'll move to the next one. We move to B. Now B and A do not match. Now this is a mismatch, so we'll now move to A. Now A matches to A, then B matches to B, then C matches to C. Now this is a match. So we have found that the pattern ABC in a very large string, I mean this a small string CAB ABC. Now this was a very small example, so it could be done and it was done in very less time. Now, but if there's a huge database like of Google, then how to find, we'll discuss such algorithms in later slides. Yeah. Search engine optimization. Search engine optimization, we read a large web page and we find matches for a pattern manually. Now that is a tedious task. We can't do that. So now in that case, we'll use regular expressions and some algorithms like Robin, Kurt, Knuth, Morris, Pratt, and all those. These will be discussed in brief in later slides. For now, we need to know that we can also use the NDFA approach, but the NDFA approach uses backtracking, so that backtracking is not feasible for us because we need to, like when we Google, we want the result to come instantly. So that's why we cannot use the NDFA approach. Google will apply some other algorithms like this Robin, Karp and Knuth Morris Pratt, which will give the answer in linear time. The So here I've discussed the algorithms that Cloudflare and Google used to have. So Cloudflare used to have NFA in backend. Now NFA uses backtracking as I discussed in the previous slide. This used to consume a lot of time. Now they finally went to using the DFA approach, which is used by Google. Now the DFA, in DFA we know the direction where we have to go definitely. Like we won't have 0 to one state and that 0 to another state. We can't have that in DFA. DFA we know where we have to go. So Cloudflare also implemented that, which is way more efficient than NFA. Now we'll discuss the Karp-Rabin algorithm. The Karp-Rabin algorithm is using a rolling hash function. What it does is that it assigns hash values to each character. Then we can match those hash values and then we can see if the given text is in the huge pattern or not. Then this achieves this goal in linear time, which is much efficient. The naive approach is basically just what I discussed in previous slides, where I took the example of C, A, B, A, B, C, and we had to find the pattern A, B, C in there. Now we checked for each iteration like manually. It took time of n into m, where n is the length of the pattern and m is the length of the text to be searched. So now it was very less efficient if we take the whole like 1,000 words. If there are 1,000 words and we have to search for 3 characters, no, that's not efficient if we use the naive approach. If we use the Karp-Rabin algorithm or the algorithm called Knuth-Morris-Pratt, which we'll see in the next slide, it is way more efficient. What Knuth-Morris-Pratt does is it uses the concepts of prefix and suffix. Prefix is the part of the string that is there in the front, and suffix is the part that is there in the end. So what Knuth-Morris-Pratt algorithm does is it takes the longest prefix of a string that is also the suffix of the previous string. So this is very efficient. This can be discussed at length, but it would increase the length of the video. So let's move on. Now we take a case study on regular expressions. Now we have a huge data of date, email and telephone numbers of various employees in a company. And we want to search for an email of a particular person. Now if there are 1,000 employees, we can't just manually go to every email and then match. So for that we'll have a regular expressions. This is where regular expressions come into play. So the problem statement is that we have a custom browser that represents data in a tabular form. Then that data is filtered by the table columns. We'll mention the date, then the time. I mean, it can represent the date and time of the employee that joined the company. From that will be unique for everyone. So we can use regular expressions. The regular expression is given in later slides. So here I have explained why we use regex, not just like going through all the data, which I have also discussed in the previous slides, I know, but here it becomes more clearer. Why? Because instead of going through the whole calendar, we can just write a regular expression that will that will be in the format of how we want the date, right? How the date already exists in the database. In that format only the regex will be there. Okay, so we'll start reading the regex from left. So this is bracket 0 dash 9 1 comma 2. Now this 1 comma 2 represents the number of digits that are there in the date. Then after that it's there the month followed by the year. So year has 4 digits, then month has 2 digits, date, month, year, followed by the time. The time can be like anything from 0 hours to 23 hours, right? So it is 0 to 9, 0 to 9. Time is just hours, minutes. That's it. So on this slide we have discussed why the previously generated regex will not give the correct output that we want. Why will it not give the correct output? Because it will also generate partial instances of the strings. Like if the date is 070424, so it will match 07 with 07, the first part of the regex, that will be printed. Then it will move on to 07 hyphen. Even that as a separate string will be printed. Such partial instances will be printed which we do not desire to have. So we will write a new regex which is discussed on the next slide. Now the problem mentioned in the previous slide can be solved by using the regex that is given below. Now here we see that extra symbol we have used here is dollar. This dollar represents the end of the string. That means we have put this dollar like here in the second row we have put dollar. That's where the string ends, or another regular expression we can write which is followed by the previous one. This dollar basically it tells that string that is printed, that whole string should be printed. Dollar represents the termination. So what are the results of the case study? This is the regular expression, and the text that we gave as an input is 1111. Now these are all the instances that are generated. These are all the matchings of with the regular expression. The final result is this 11112023. Now the partial instances are generated along with the final result. Now this is just to show that the regex is working. This is not the ideal one. Alright. So these are the references that I've included, the websites that I followed for creating this PPT. Thank you so much. This marks the end of my presentation.